3.4b, clearing fractions with least common multiple. A good strategy for fractional equations is to multiply both sides of the equation by the LCM of the denominators. As you saw before in a previous video, dealing with fractions can kind of be a pain. So why don't we turn our equation with fractions in it into an equation without any fractions, just whole numbers as the coefficients and things adding. So the way we do this is we first find the LCM of the denominators. So let's work on our first example. Solve 1/2 x plus 3/4 equals 9/3 for x. So we first find the LCM of the denominators. LCM of 2, 4, and 3. Now we're finding the LCM of 3 things this time, which is a little different than 2, but not many. All we have to do is use the highest power of each unique factor of all 3 numbers after we break them into their prime factorizations. Well, 2 is already in its prime factorization. The factorization tree looks like this, just 2. 4's factorization tree looks like this, and 3's factorization tree just looks like this. So 4 equals 2 squared. What's the highest power of all of the 2's? 2 squared. And what's the highest power of the 3's? 3. So this is our LCM, 2 times 2 times 3, which ends up being 4 times 3, which is 12. So now we take this LCM of the denominators and we multiply both sides by 12. So let's go ahead and do this. We multiply the quantity by 12 and we multiply this by 12. It's very important to multiply whole sides if we're going to use the multiplication principle. We have to multiply the whole left side. So doing this, 12 times 1/2 x. This becomes 12 over 2x. Plus 12 times 3 is 36 over 4 equals 9 times 12 is 9. If I write this out, 12 times 9, 18, 108. This is 108 over 3. So now, if I simplify these fractions, this becomes 6x. 12 divided by 2 is 6. Plus 9, 36 divided by 4 is 9, while 108 is 36. So 6x plus 9 equals 36. Now this equation, which is equivalent to the other one because all we've done is multiply by the same thing on both sides, is much easier to solve. So let's subtract 9 from each side, and we get that 6x ends up equaling 27. Divide by 6 on both sides, and we get that x equals 27 over 6. And if we divide top and bottom by 3, we can reduce this so that x equals 9 over 2. And that's the solution to our equation. So we ended up making this problem with fractions into an easier problem without any fractions at all. Example 2. A tank is 250 feet in volume, but needs to be 450 feet in volume. How many 50-foot cubes must be welded to get it there? So we need to set up an equation representing the situation. So we have a tank that's already 250 feet cubed, and we're adding an unknown amount of 50-foot cubes to it. In total, it needs to be 450 feet cubed in volume. So now we have this algebraic equation to solve. We start out by subtracting 250 to get the x term by itself. These cancel, and we're left with 50x equals 200. If we divide both sides by 50, x equals 4. So we need 4 of these cubes to be welded to get it there.